Hey guys, now we're going to look at how to multiply polynomials. So we're going to start off with an example that is in your book. If you want to look at it in your book, it's on page 340. I'm going to multiply the two polynomials x plus 3 and x minus 2. So both of these are binomials. They're linear because they're first degree. The two individual factors here are linear. Now, once we get them multiplied together, what it's going to produce will not be linear, and you'll see that at the end. So when we multiply polynomials with algebra tiles, we're going to first create sort of a multiplication template like this, and then we're going to model each polynomial outside of this template. So I'm going to put x plus 3 down the left side over here. So remember, x is the green tile, and then I need 3 ones. So 3 of these yellow ones over here. And that's going to make x plus 3. And then across the top, I'm going to put x minus 2. So up here at the top, I've got x. I need to rotate this around. So there's x. And then minus 2. So that's going to be 2 of the little red squares. So there's x minus 2. And this works very similar to the way the multiplication table worked when you were in elementary school. To figure out what this is equal to, I have to fill in inside this template by making a complete rectangle. So I need some sort of tile that's going to fit right here into this space. It has to be as long as an X tile this way, and it has to be as wide as an X tile this way, and it has to fill in there. So let's look at the tiles that we have available over here to choose from, and we know that this is a positive x and this is a positive x, and when we multiply a positive number times a positive number, it equals a positive number. So I need a positive x squared tile to fit right there in that space, because it completely fills in the length of the x tile and the width or height of the x tile. Okay, then just like we did with multiplication tables, I'm going to go ahead and come down. I'm going to come across this way, and I'm going to come down this way, and where those come together, I need some sort of a tile that's going to be this tall, like the little yellow one, but it's going to be this wide, like the X. Now again, it's a positive times a positive, so I'm looking for a positive tile to put in that space, and the one that fits into that space is an X tile. Now you can probably see here that I need the same thing to fill in right here and right here. So I'm getting closer to filling in my rectangle. Now I need to figure out some sort of tile that would fit to go across from the X tile, down from this little -1 tile. Now remember, these are negative, so that's going to give me a positive for the X tile times a negative for the -1. So positive 1x times -1. So the tile that's going to fit into that spot has to be a negative tile. A positive times a negative is a negative. So that's going to be a negative X tile. Same thing right here. So I'm getting really close to finishing up my rectangle. All I need now is to multiply this +1 times this -1. And a +1 times a -1 is a -1. And that is conveniently what fits right here in this space. I'm going to go ahead and fill those in here. So now we can see the answer to our problem. Our problem was x plus 3 times x minus 2. The answer is everything that is inside of this bracket. So now we just have to read off the tiles that are inside of this little multiplication bracket that we have. So the big blue square is x squared. And then I have plus x. So there's a positive x, another one, that's 3x. And then I have minus 2x. Think about your zero pairs here. I can get rid of one of these with one of these. There's a zero pair. I can do the same thing again right here. What I have left is 1x, so that's plus x. And then I have minus 6. So that means x plus 3 times x minus 2 is equal to x squared plus x minus 6. Okay, I want to look at another example, and this time we're not going to use the algebra tiles. This time we are simply going to use the distributive property to multiply. And I'm going to look at x plus 2 times x minus 8. X plus 2 times x minus 8. Now, we've done the distributive property before. You know that you take the first number out here and you carry it through and multiply it by everything that is inside that second set of parentheses. Okay, so x times x, that's going to be x squared. And then we have x times negative 8, that's minus 8x. And then I'm going to do the same thing with the 2. I'm going to multiply the 2 times everything that is inside the second set of parentheses. So that's going to give me plus 2x. 2 times x is 2x. And then 2 times negative 8, that's going to give me minus 16. So I have x squared minus 8x plus 2x minus 16. Now what you may have noticed is that right here in the middle, I have some like terms, and I do need to combine those like terms to get to my final answer. X squared minus 6x minus 16. All right, let's look at another problem here. 2x minus 3 times x plus 5. So again, I'm going to do the distributive property. I need to multiply the 2x times everything that is in the second set of parentheses. 2x times x is 2x squared. And 2x times 5 is 10x. So 2x squared plus 10x. Then I have to multiply the negative 3 times everything that is in parentheses. That's going to be negative 3 times x, which is minus 3x, and then negative 3 times 5, so minus 15. Now, once again, I do have some like terms right here in the middle that I need to combine. That's going to give me 2x squared, and then 10x minus 3x. That's going to be plus 7x, and then minus 15. So 2x plus 3 times x plus 5 is equal to 2x squared plus 7x minus 15. Okay, one more thing I want to look at is multiplying by using a table, because you can draw a little table that kind of resembles an Excel spreadsheet. We're going to look at that same problem that we just worked. 2x minus 3 times x plus 5. And this time we're going to work it by using a table. Now, my table needs to have 2 squares across the top and 2 squares down the side, because each of these is a binomial. So since each one has 2 terms, I need 2 boxes across the top and 2 boxes down the side. I'm going to write one term out beside each box. So here's 2x, and here's minus 3. And then across the top, I'm going to write x, and then I'm going to write plus 5. So you see how I've split those up. I took my 2x right here, and then I did minus 3 right here. And then in my other expression, I took my x, and then plus 5, like that. So now that I have made the table, I'm going to multiply, and this is very similar to what we did with the algebra tiles. It works just like the old multiplication tables did when you were little. We're going to just multiply, start here with the 2x and the x. So 2x times x is 2x squared. And then we're going to multiply the negative 3 and the x, and negative 3 times x is going to give us a minus 3x. And then I'm going to go all the way across. I'm going to say 2x times 5, and that's going to give me 10x. And then I'm going to say negative 3 times 5, and that's going to be negative 15. So once I've filled that box in, all I have to do is write down my answer. So 2x squared minus 3x plus 10x minus 15. And combine my like terms. Now, if you want to combine your like terms before you write your final answer, that's perfectly fine. Your like terms are going to be on the diagonal right here. So that's 2x squared plus 7x minus 15. So you are welcome to use this table method if you would like to. Now, there's one more method that's discussed in your book. It's on page 343. It's called the FOIL method. We're going to look at that in class tomorrow. It's kind of a shortcut. It's a gimmick. It's a trick. It only works when they are both binomials. The distributive property, or the table, will work for every kind of polynomial in the whole world. But this FOIL method only works when both of them are binomials. It is fast. It will save you some time if you learn it, but it's not absolutely required. Okay, I want to look at one more example, and that's a binomial times a trinomial. Here's our binomial, x plus 5, and we're going to multiply it times a trinomial, x squared minus 3x minus 2. Okay, binomial times a trinomial. Again, all we're going to do is distribute. So I'm going to take this x and distribute it all the way throughout the parentheses in my second expression. So x times x squared is going to be x cubed, and then x times negative 3x is going to be negative 3x squared, and x times negative 2 is going to be negative 2x. The next thing I want to do is take the 5 and distribute that all the way through that second set of parentheses. So 5 times x squared, that's going to give me 5x squared. And then 5 times negative 3x, that's going to give me negative 15x. And 5 times negative 2 is going to give me negative 10. Now you may have noticed that instead of writing that straight out across there, I lined up my like terms. The reason I did that is it makes it a little easier to simplify out and write my final answer. You don't necessarily have to line up your like terms vertically like I've done. I just think it makes it easier and saves some time, so I prefer to do that. So that's going to be x cubed plus 2x squared minus 17x minus 10. Now again, you can use the table method if you'd like to for this. This time, since I have a binomial times a trinomial, I need 2 boxes for my binomial. So there's x plus 5, and I need 3 boxes for my trinomial. X squared minus 3x minus 2. And again, I'm just going to multiply. I'm going to come together horizontally and vertically and multiply to get what goes in each box. So here we go. X times x squared is x cubed. And then x times negative 3x is negative 3x squared. And x times negative 2 is negative 2x. So then I'll do the 5. 5 times x squared is 5x squared. 5 times negative 3x is negative 15x. And 5 times negative 2 is negative 10. And just like before, if you look on the diagonals, you have your like terms, and we are ready to write our final answer, x cubed. Now we've got 5x squared and negative 3x squared. That makes 2x squared. And then we have negative 15x and negative 2x, which is negative 17x. And then we have negative 10. So x cubed plus 2x squared minus 17x minus 10. So I know I told you guys the video would probably be about 7 or 8 minutes long, and we did go double that, 16 minutes, but still not a horribly long video. I hope you watched all the way through to the end, and you will be ready to work some problems in class tomorrow. Have a great evening.